Use the function f of x to answer each question and sketch the graph of f of x. Does the parabola open up or down? You can see by the leading coefficient being negative that this parabola is going to be opening down. Then it says, what is the vertex? In the previous page, we saw the formula for vertex, at least the x-coordinate, is x is negative b over 2a. Well, b is 9 and a is negative 5. So we have negative b over 2a. That's going to be negative 9 over negative 10, or 9/10. To find the y-coordinate of the vertex, we substitute the x back into the equation. So y is equal to negative 5 times 9/10 squared plus 9 times 9/10 minus 1. Now to save time, I'm going to put this into my calculator. Negative 5 times 9/10 squared plus 9 times 9/10 minus 1 is 3.05, which is the same thing as 61 over 20. And 9/10 is the same thing as 0.9. I need those decimals because it's easier to graph them if I know the decimal value. But when I write my vertex, I'm going to write it as the point 9/10, 61/20. So if I go to my grid and graph that, I'm going to go to where x is almost 1 and where y is just more than 3. So somewhere in here. We also know that this is going to be opening downward, so we should have a y-intercept and 2 x-intercepts. The axis of symmetry, remember that is the line that goes right through our vertex. It goes right through the center of our parabola. So it is x equals the x-coordinate of the vertex. For the y-intercept, remember you let x equal 0. So we have y is equal to negative 5 times 0 squared plus 9 times 0 minus 1, which is just negative 1. So your y-intercept is the point 0, negative 1. That's going to be here. Then it asks us to find our x-intercepts. To find x-intercepts, remember you let y equal 0. So we have 0 is equal to negative 5x squared plus 9x minus 1. So at this point we need to either factor or use the quadratic formula. I'm going to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 9 plus or minus the square root of 81. Negative times negative times negative is a negative. 4 times 5 is 20, times 1 is still 20. And that's over negative 10. So negative 9 plus or minus the square root of 61 over negative 10. Well, remember in class we talked about how the negative could be at the top or at the bottom. Well, if you move that to the top, it would look like that. All I did was take this negative and move it to the numerator. So this negative that was here is now up here. Distribute that negative 1. That becomes a positive 9. This is plus or minus. Well, the opposite of plus is minus, and the opposite of minus is plus. So don't we still have plus or minus? I know that was kind of strange. You can rewind and play that again if you need to. So we have our two x-intercepts. We have the point 9 plus the square root of 21 over 10, 0. And we have the point 9 minus the square root of 61 over 10, 0. These are our two x-intercepts. But if I need to graph those, I need to know some sort of decimal that represents them. So we have 9 plus the square root of 61 divided by 10. So this one is approximately 1.68. And then the one with the minus in it is about 0.12. So we can go to our coordinate plane graph where x is 1.68. It's about here, I guess. And where x is also 0.12, which is really close to 0. So we have our vertex. We have our two x-intercepts and our y-intercept. And we can sketch our graph from there. I didn't draw that very well, but you get the idea. What are the domain and range of this function? Well, remember, for quadratic functions, the domain is going to be everything because it goes forever to the left and forever to the right. So the domain is all real numbers or negative infinity to infinity. The range, remember, you start at the lowest y. The lowest y is down there at negative infinity, but it comes all the way up and stops at this point. Do you remember what this point was? This is your vertex. That's the point 9/10 and 61/20. So it comes from negative infinity, goes all the way up to 61 over 20 and stops. So your range is going to be negative infinity to 61 over 20. So what if you are asked to write a general form into a vertex form? The instructions for doing that are here, but I'm just going to work through an example with you so that you can see how to do this. Remember from a couple of chapters back, we talked about quadratic equations and how you can solve them by completing the square. That's what we're going to be doing here. So we have this function, f of x equals x squared minus 4x plus 3. We want to write it in vertex form. So this is what we need to do. First thing is make sure a, this number here, is 1. If it's not, we have to do that first step up there. Factor a out of the first two terms. We'll do one of those in just a minute though. The next thing you want to do is kind of scoot the constant over just a little bit, because now we're going to complete the square, which means we're going to put something here and here. To complete the square, you take half of b and square it. Well, half of b, half of negative 4 is negative 2, and negative 2 squared is 4. You want to add that here. But you can't just randomly add a number to a function. If you were to simplify this, combine your like terms, you would not get what you started with. That means we have changed this function. So to keep it from changing, we just have to undo what we just did. So if I add 4 here, I'm going to subtract 4 here to keep it all balanced. Now looking at just this part right here, we have, if you want to factor this, factors of 4 that add up to negative 4 would be a negative 2 and a negative 2, right? 3 minus 4 is negative 1. This is just that factored. Okay, so we have x minus 2 all squared minus 1. We have written it in vertex form. Does this parabola open up or down? Well, A is positive, so it opens up. What is the vertex? Well, the vertex is HK. So the vertex is 2, -1. And if you want, you could go ahead and graph that. What is the axis of symmetry? The axis of symmetry is the vertical line that goes right through the vertex. So it's x equals whatever the x coordinate of the vertex is. In this case, it's 2. How about the y-intercept? For a y-intercept, remember you let x equal 0. So we have y is equal to 0 squared minus 4 times 0 plus 3, which is just 3. So your y-intercept is the point 0, 3. Now we can graph that one. 0, 1, 2, 3. We need our x-intercepts. That's where y is equal to 0. So we have 0 equals x squared minus 4x plus 3. This time the function will factor. Factors of 3 that add up to -4 would be a -1 and a -3. Just want to double check my work. So then we set each one equal to 0 and solve. We add 1, x equals 1. We add 3, so x equals 3. Your two x-intercepts are 1, 0 and 3, 0. Now that we have all of this information on our coordinate plane, we can sketch our graph. What's the domain of this function? As usual, this is quadratic, so the domain is everything. Again, that's because it goes forever left and forever right. The range, start at the lowest point, go to the highest point. Well, the lowest point is -1. It includes -1, so we have a bracket, and it goes forever up, so we have infinity.